Okay, so let's talk about tangent, cotangent. I will post your homework at 6th period today. Forgot to post it yesterday, so I'll post it. You only do the problems that relate to tangent and cotangent. So if you see secant and cosecant, don't do those yet. I'll talk about those tomorrow. So let's go and look at the unit circle. The unit circle has the following degrees or ingredients: 0, pi over 2, pi, 3 pi over 2, and 2 pi. And then you can see the ordered pairs there. Remember, our ordered pairs of x and y relate to cosine and sine. And so tangent comes from sine divided by cosine. That's all stuff that we talked about before. So let's find the tangent of each of those points. So again, here's your point: 0, pi over 2, pi, 3 pi over 2, and 2 pi. And if I go fast, you just need to raise your hand something. With homeroom today, I feel like I need to hurry.
Yeah.
Correct. It's y over x. And so if I'm to find tangent at 0, tangent is equal to, look at your ordered pair, 0 over 1, which is what value? What value? 0. At pi over 2, tangent is equal to 1 over 0, which is what value? Undefined. So UD, undefined. At pi, tangent is equal to 0 over negative 1, which is what value? 0. And at 3 pi over 2, tangent is equal to negative 1 over 0, which is what value? Undefined. So we have a pattern here. Tangents at those points are either 0 or undefined. What have we done in the past to show when we graphed that that part of the graph is undefined? What do we use? Think of your graphs of fractions. Like 10 over x minus 2. Where is that graph undefined? 10 over x minus 2. What can x not be? 2. So what did we do with that? We drew what into the graph? An asymptote. So we're going to use asymptotes here at pi over 2 and at 3 pi over 2. So we're going to put in vertical asymptotes because the graph can't cross in those places. So an interesting thing occurs. We are going to graph just plain y equals tangent of x. And you're going to see a couple of things occur. Thing one, the period changes from what we're used to with sine and cosine of 2 pi, it changes to pi. And when we graph it, you'll see why. Because one full wave is only a pi in width before it repeats itself. Whereas in sine and cosine, you need 2 pi for the whole wave to occur before it starts to repeat itself for a normal sine and cosine graph. So for here, we've already realized that at pi over 2 and 3 pi over 2, we're going to have asymptotes. So the asymptotes are going to be in multiples of odd pi over 2. And I say odd pi over 2 because if we have an even pi over 2, like 2 pi over 2, doesn't that mean pi? 4 pi over 2, would that be 2 pi? And we know that at nice perfect pi's, we're going to have a value of tangent is 0. So it has to be an odd, like 5 pi over 2, 13 pi over 2. All of those are going to have asymptotes. And then zeros. Tangent does cross the x-axis, isn't that what 0 is? So tangent has the same zeros as sine. And the reason is, if you think about it, tangent is sine over cosine. Whenever sine is 0, that means 0 is in the numerator, the value of that fraction is going to be 0. So whenever sine is 0, tangent is 0 too. We're going to have the reverse for cotangent, but we'll get to that in a minute. So the equation for your vertical asymptotes does look like that. And all I really care about is my period and my asymptotes. That's it. You no longer will hear me talk about amplitude or really a phase shift, because all of those can be found and determined by finding your asymptotes. Your asymptotes will also give you the shape of your graph as well. So let's go ahead and partition this out as we have in the past. This is 0. This is pi over 2. 3 pi over 2. Oops. I did that second period too. How about pi? 3 pi over 2. And then 2 pi. So I'm going to start there. I will tell you, however, that well, I'm going to go ahead and put these in first. So let's look at our two undefined places. Pi over 2. I'm going to draw in, you must use the straight edge, don't hand draw. A dotted line to represent that our graph can't cross them. And then also at 3 pi over 2. All I need are two asymptotes, and that gives me the pattern for all asymptotes for the graph, because all asymptotes will be equal distance apart. So how far apart are those, grid line wise? I got 4 grid lines. So every fourth grid line is going to be another asymptote. And then I'm going to partition this out, and I'm just going to name every other one. So from here to here is pi. From here to here is 2 pi. Every 4 grid lines is going to be another pi. So then I have 3 pi. Then I have 4 pi. And then on the left, negative pi. And we'll see why in a minute. I'm going to put negative pi over 2 as well. So I'm going to put in all my asymptotes. So every 4, put in a dotted line. You okay with that? All I did was use my normal asymptotes for pi off of the unit circle, pi over 2 and 3 pi. And then I marked off in my case, every 4 grid lines apart to make more asymptotes. And they'll go on forever. Then your tangent graph looks very similar to the y equals x cubed graph. It's an S-shaped curve. It starts in the upper right corner and it goes to the lower left corner. You have to find the middle between your asymptotes. The middle between your asymptotes would be the zeros. So the middle between these two asymptotes is pi. So I'm going to take and I'm going to hug the asymptote and I'm going to go towards that 0. I'm going to hug the asymptote, go towards the 0, and then hug towards the other asymptote. There's my curve. But you have to know that tangent starts in the upper right. Somehow you gotta get that stuff in your head. Question. Because as I look at the unit circle, I determined where is tangent undefined. Tangent on the unit circle is undefined when 0 is in the denominator. So when I had 1 over 0, tangent is undefined at pi over 2. Also, it's undefined at 3 pi over 2. Those are the 2 places. So I started with those, and then I can find all my other asymptotes just following that same pattern. I happen to partition my graph into 1/4 pi. I just used 4 grid lines to represent pi. And so, I mean, if you went by halves, right, right. I just chose to partition my graph by fourths. you might have partitioned your graph by halves, and you could do that. Then your asymptotes are going to be closer together than mine because you changed your scale. It's different than mine. Our graphs are still correct. It's just when you adjust your scale, the graphs can look squished or stretched out. And I'm going to use the same scale all day today for you so that you can see the changes that occur when we change things on the equation itself. Any other questions before I finish out my graph? All right, so I'm just going to take my zeros and continue out that pattern. So just something that I'm going to show you on this graph just as an aha. So remember I said up here that tangent has the same zeros as sine. So if I were to graph sine on here, assuming that this was a distance of 1 and this was a distance of -1, I'm just going to graph one period of sine. And so if I were to graph sine on here, sine would be here at 0, up, 0, down, 0. Isn't that one period of sine? Doesn't sine have exactly the same zeros as tangent does? And so again, when sine is 0, tangent's going to be 0 because sine is in the numerator of the fraction for tangent, or the ratio. All right, so let's look at cotangent. So in order to look at cotangent, I need to find its asymptotes, because the important thing about graphing tangent and cotangent are finding the asymptotes. So as I look up here, wherever tangent is undefined, won't cotangent be 0? And wherever tangent is 0, won't cotangent be undefined because they are reciprocals of each other, inverses? So I know that here, cotangent will be undefined, and here, cotangent will be undefined because that's the reciprocal of 0 over 1, it would be 1 over 0. And that creates an undefined value at 0 and at pi for cotangent. So if you know where tangent is undefined, you automatically know where cotangent is undefined. So you only have to learn one of them. And by the way, let me just give an aside as far as tangent goes. For whatever reason, most pre-calc and calc textbooks, well, I actually kind of know you'll see it later, but instead of using pi over 2 and 3 pi over 2 for the asymptotes for tangent, you have to go backwards. If I go backwards, what is this value here? What's coterminal to this value here? If I go backwards, now negative what? Pi over 2. So this is exactly equal to negative pi over 2. Oh, by the way. So you will see me on the next page when we actually calculate proper asymptotes that negative pi over 2 and 3 pi over 2 are coterminal. And if you look here, wasn't there an asymptote at negative pi over 2? And at pi over 2. Aren't they the same distance apart as these two? As they all are? So you'll see how I use that in a minute. But let's look at cotangent. So cotangent's asymptotes are in multiples of pi. Every pi. 0, pi, 2 pi, 3 pi, 4 pi, 5 pi. So every multiple of pi is an asymptote for regular cotangent. Then cotangent has the same zeros as, what do you think? What's in the numerator? Cosine. Cosine's in the numerator of cotangent, because cotangent is cosine over sine. So therefore, when cosine is 0, so is cotangent. So let's find and put in our asymptotes. So I'm going to partition my graph exactly the same way. This is pi over 2. This is pi. 3 pi over 2. 2 pi. And I'm just going to go every other. And again, you'll notice that cotangent also has a period of pi because it only takes one wave for it to repeat itself, and that's a distance of pi. And you note that the vertical asymptote equation is multiples of pi. Bless you. So let's put in the asymptotes we just came up with. So cotangent is undefined at 0. So 0 happens to be the y-axis, so make sure it's quite clear that you're putting a dashed line there. So I kind of put it right next to it so you can still see that it's dashed. Are you okay with that? That's 0. Because remember up here we determined wherever tangent is 0, cotangent is undefined. So if tangent's undefined here, cotangent's undefined here. They're never undefined in the same place. So if you remember that for tangent, then cotangent has to be 0 and pi. And so we're going to put our asymptotes here at 0 and also at pi. How far apart are these two asymptotes? How far apart from 0 to pi? Pi. There's our period. And cotangent looks like this. The very center of this particular set of asymptotes is at pi over 2, and cotangent goes in the opposite direction as tangent. It goes from the upper left and it heads to the lower right. So we're going to start in the upper left, and we're going to hug the asymptotes down to the lower right. So cotangent looks identical to tangent, except the curve is reversed and the asymptotes are in different places. So then I'm going to finish out my pattern of asymptotes. So at every pi, I'm going to put an asymptote. So all I did was went in multiples of pi. 4 grid lines apart. And then I'm going to finish out my pattern of going upper left, hugging through 0 to the lower right. I'm going to do 0 in the very center. And drawing the curve. Now we don't have full periods here on the right and the left, but you do know that your 0 is 2 units away from the asymptote, so I can still put the 0 to the right of 4 pi. And I can still approximate as much of that curve as I can put in. And on the left, I know that my 0 is 2 units to the left of negative pi, and it's coming from somewhere up here down there. So for partial periods, you do need to approximate a partial curve. So any issues, problems, or concerns with tangent or cotangent and their general graphs? You understand where I found the original asymptotes. Once you find the first two asymptotes, the rest of the asymptotes just fall into place through a pattern. Alright, so can we flip? We good? Nobody's complaining, so okay. Alright, so then we're going to look at more complicated versions of tangent and cotangent. You have a couple of things that you must know. It's really not that hard. So here are the things that you must, I really meant to highlight that one. That's all right. You must be aware of the following 3 items. If you're to find your new asymptotes for tangent, we're going to use these two. You can use whatever two you want to. So on the unit circle, we use pi over 2 and 3 pi over 2. But I just showed you that 3 pi over 2 and negative pi over 2 are coterminal. Why do they use those? Well, later on, we have some restrictions for domain, and tangent's always restricted to the first and fourth quadrant, which is what those border. So my guess is that's why we're using plus in your calculations. These are smaller numbers than 3 pi over 2. I could use whatever I want to though. So if I'm trying to find my new asymptotes, because your asymptotes can change, my asymptotes can get wider or narrower. Wider or narrower. So that's a horizontal stretch or a horizontal shrink. A horizontal stretch can create a vertical shrink, by the way. A horizontal shrink can create a vertical stretch. And you'll see the shapes of the graph change. So on this graph, I could use these two. I could use 3 pi over 2 and 5 pi over 2 to find my new asymptotes if I wanted to. They're just bigger numbers, so be careful. So who wants to do that? So the smallest numbers in asymptote-wise here are these two. So you can use whatever you want to. The suggestion is that you use these two. And then for cotangent, we generally always use 0 and pi because they're easy to work with. So I would write yourself the following note. You're going to go, well, where did you get those? I got them off the unit circle. You can use any one of the asymptotes. These are the typical ones chosen. Any ones that you want, you don't have to use those two, but you need to use the two that are the same distance apart as every other one. But my suggestion would be to use those two. Yes.
Is the first one like negative pi over 2, is the second one supposed to be pi over 2?
No, that's what I'm saying. Is that instead of using 3 pi over 2, we're not going to use negative pi over 2. You can use 3 pi over 2 in place of negative pi over 2 because 3 pi over 2 and pi over 2 are the same distance apart, asymptote-wise as those are. The number for 3 pi over 2 is just bigger than negative pi over 2. So if you're more comfortable using what's on the unit circle because that's what you remember, fine, you can use that. Your original two asymptotes would be different than mine, but they'll be the same distance apart, and then you can just use those to approximate your pattern. So it'll work the same. Is everybody clear on that? It's weird that they go ahead and switch that. I know. Because negative pi over 2 we don't use being on the unit circle, but we have to go back. Alright, so we're going to, and then also, a negative sign is important, reverses the curves. So a negative in front of a tangent reverses the curve so it looks like a cotangent curve. It doesn't affect the asymptotes, but it just changes the direction. And same thing with a negative in front of a cotangent. It reverses the curve so it looks like a tangent curve. That's all you're doing. It's essentially a reflection over the x-axis. We're not going to do a negative in here though. We'll do a negative outside, but not a negative inside. And then the other thing that, it's not important that you know this per se, but this is what's happening. We really don't use the word amplitude or phase shift when we're talking about cotangent and tangent. Because if you find your asymptotes, they will give you the shape of the curve. And that's really all that's important. So I don't really care that I have a 3 in front here. My asymptotes are going to stretch, do that vertical stretch for me. Really this has an effect on the middle part of your graph, but I don't really care much about that. I'm more concerned when you find the zeros and can you graph those asymptotes. So write yourself the following note. The proper asymptotes will create the correct shape for the curve. So, here we go. Let's look at this one here. We have y equals a tangent of x divided by 2. This says that if the number is less than 1, it means the curve is flatter. That means in the middle of the curve. Let's see what that looks like. Versus if this number is greater than 2, it means a straighter curve. Well, I can't tell what the coefficient of x is, and I know that they're saying amplitude, but this is what affects that flattening or the straightening of the curve right here. And this is all I care about is what's here. This is not really a 2, what is it? Yeah, it's y equals the tangent of 1/2 x. So this is a number that's less than 1. So it should mean that I have a flatter curve. So as I come through here, that curve is going to really flatten out. So how do we find our asymptotes? Because my asymptotes have now changed, because what we learned before, isn't this a period change? The coefficient in front of x is really a period change, isn't it? And that period change creates a horizontal stretch or a shrink. And so our period is going to change from pi because I have something in front of that x. So let's find our asymptotes. All you're going to do is take exactly what's happening to x over 2, and you're going to set it equal to your normal asymptotes for tangent. I'm going to use what they like to use, which is negative pi over 2 and positive pi over 2. You can use 3 pi over 2 and pi over 2. You can use that as well, because that's directly off in the circle. I'm going to use this because this is typically what you'll see in most textbooks. And then all you can do is solve for x. So to solve for x, I'm going to multiply by 2 for both sides. So I get x equals pi for my first one, negative pi. Forgot about my negative. And then x equals positive pi. So let's look at our period. To find your period, you need to take the two asymptotes and just subtract them. That'll give you the distance. I like to take the bigger and subtract the smaller. So the bigger is positive, the smaller is negative. So I'm going to take pi and subtract negative pi. I add the opposite, and don't I get 2 pi? So my period is now switched from pi, it's stretched to 2 pi. So I have a horizontal stretch going on here. So this is actually less than 1, it means it's going to flatten out that curve. So let's put in our asymptotes. I'm going to use the same partitioning that we did before so you can see how it changes that curve. So this is 0. Here's your pi over 2, pi, 3 pi over 2, and 2 pi. And then every other increment. So where did I get these from? Again, I'll always use those same ones, but I've got new ones this time. Negative pi. I'm going to put my first asymptote here at negative pi, and then add positive pi. How far apart are negative pi and positive pi? What's their distance? 2 pi. And so that's 8 grid lines. So every 8 grid lines, I'm going to put my asymptotes in, as many as I can put in. So here's 2, 4, 6, 8. I'm going to put another asymptote in. 2, 4, 6. I can't put another one in on the right, and I definitely can't put one in on the left. So I can only get 3 asymptotes in on this graph. My zeros are always in the very center. The very center between those two is 0, and because it's tangent, I'm going to go from the upper right, hug that asymptote, really exaggerate the flattening out of that curve, and hug the other asymptote. Here's my 0, hug that asymptote, exaggerate the flattening out of that curve, and go the other asymptote. Now when you have your partial, you still know that your 0 is 4 units away from, 4 grid lines away from the asymptote. So I'm going to approximate what that line should look like. Now over here I can't get to the 0. And I guess technically I could go like this. I could get a partial. So if you look at that graph compared to plain cosine, there's a whole lot fewer periods. There's period is stretched out. Issues, problems, or concerns with that? Alright, so what happens if we change this from dividing by 2 to multiplying by 2? And then what else do you see on here? We have a negative. A negative implies a change in direction. The curve reverses itself. So write yourself a note. This negative, the negative, is a reflection. It reverses the curve. And in parentheses, so it looks like cotangent. The asymptotes won't look like cotangent, but the shape of the curve itself will resemble cotangent. So we're going to do the same thing we did before. We're going to find our asymptotes. I'm going to take what's happening to x, this whole 2x, take 2x and set it equal twice to the same asymptotes I just used before for this tangent. So the asymptotes I used for tangent are negative pi over 2 and pi over 2. Those will remain the same. All I have to do is solve. So it's going to freak out some of you. Let's stop and think about it. If I solve for x, what do? Divide by 2. I don't really want to divide a fraction by 2, so instead of dividing by 2, we multiply by the reciprocal of 2, which is 1/2. Dividing by 2 and multiplying by 1/2 are the same thing. So I'm going to divide by 2 and multiply by 1/2. And so I end up with x equals negative pi over 4. And x equals positive pi over 4. So we need to find the period, so the distance is. So the period would be the difference between these two. So I want to take the bigger pi over 4 and subtract the smaller, which is negative pi over 4. Add the opposite. Pi over 4 plus pi over 4, 2 pi over 4, which is pi over 2. So what's happened to my period? It went from what to what? What's the normal period for tangent? Pi. So we went from pi to 2 pi. So what is this that's happening? A horizontal shrink. Now a horizontal shrink is going to have the same effect as a vertical stretch. So look what happens. I'm going to use the same increments as before. 0, pi over 2, pi, 3 pi over 2, and 2 pi. And then every other one. So I've found my new asymptotes. Negative pi over 4, pi over 4. This is going to be fine. Here's negative pi over 4, and here's pi over 4. Don't draw in anything yet other than that. Why is this going to be fun? First of all, the distance between those two is pi over 2. Second of all, won't there be a lot of them on the graph? It's a lot more work for us. So every other grid line, so every 2 grid lines, you want to put in an asymptote. So that's the pattern, 2 apart. We're just going to reproduce it. But before you put the curve in, what do you have to watch out for? We have a reflection. So don't forget that we have to reflect it. So when I start at my original 2, which is right here, there's my 0, instead of going from the upper right, I want to go from the upper left and reverse that curve. Because that's all that the reflection does, it just reverses it. And it hugs that asymptote, goes through the 0. You want to make sure you plot that 0 point, because if I don't think you're putting it through the 0 point, you're going to lose points for that. So always plot your 0 first, and then graph. Issues with that. Okay. So we're going to do cotangent. And by the way, on the front, remember how I said cotangent has the same zeros as cosine? Well, if this were 1 and this were -1, cosine would be up here, 0, down, 0, up. And as you can see, cotangent has the same zeros. So, you're looking at this one? Did you need to see that? Okay. So then let's look at cotangent. Cotangent, this one's going to be pretty quick. Exactly the same way. I don't have any negatives, I don't have a reflection, I'm just going to find my asymptotes. So always start with your asymptotes. But what are my asymptotes normally for cotangent? If it's not pi over 2 and negative pi over 2, what would it be? 0 and pi. So I'm going to take the x over 3 and set it equal to the two different asymptotes normally for cotangent. So I'm always going to use 0 and pi for cotangent asymptotes. And then just solve for x. We just have to multiply by 3 to solve. And I get x is equal to 0 and x is equal to 3 pi. So as you can see, dividing has stretched out that horizontal stretch to that period, and my period has a distance of 3 pi minus 0, which is 3 pi. So I'm going to use the same partition as I have for the whole lesson. And we're just going to mark in our asymptotes, the new ones that we come up with, 0 and 3 pi. So again, be careful when you put your asymptote as the y-axis that you visually show that there's a dotted line. And so I got 0 and all the way over to 3 pi. How far apart are those, grid line-wise? 12 grid lines on my scale. I don't have 12 over here or 12 over here, so those are the only asymptotes I can put in there. Also, it's cotangent. The very center is going to be 6 away. So I'm going to go from the far left, because it's cotangent, exaggerate that flattened curve and hug the other asymptote. So if you get your asymptotes in there correctly, it gives a proper shape to the graph. And so I can still do partial graph up here because I know that my 0 is 6 units away from that asymptote. So I can still come from the left and exaggerate that and go as far as I can go. Same thing here. I know my 0 is here, and I'm coming from somewhere here, hugging that asymptote. Yes? I can't hear you. What? Because if I can find my 0, I know where it should end up, because I know I'm going from left to right, so I might as well put as much of that in there as I can. Any other questions on that? Okay, so when you're done filling that in, put away your notes, and we have a quiz.